Hi everyone, this is Madam Leong. I will be with you in this video session to make a brief introduction to experiment 4. The title of this experiment is Rotational Motion of a Rigid Body. Please follow the steps below to complete your practical task. Before you enter the lab, please spend about 5 to 10 minutes reading the contents of experiment 4 in your physics lab manual. Step number 2, watch the online virtual teaching video on Introduction to Experiment 4, which is this video. Step number 3, answer all the questions in the pre-lab module for Experiment 4. Check your answers and do necessary corrections. Step number 4, fill in items A and B in the jotter section. Figure out an appropriate data table to record readings that will be obtaining when carrying out the experiment. Step number 5, watch the demonstration video on experiment 4 before you enter the lab. When you are in the lab, step number 1, put on your lab coat and button up. Step number 2, remember to bring your physics lab manual and physics practical workbook for every session of practical work. Step number 3, bring graph paper, long ruler and necessary stationaries, no mobile phone or silent it, and place in the front table. Step number 4, set up apparatus, do measurements, record the readings in the data table, jot down observations and possible errors occurring during the experiment. Step number 5, you will be evaluated based on the practical skills scoring rubrics available in the physics practical workbook. For report writing, step number 1, watch the online virtual teaching video on report writing guides. Step number 2, write your lab report in the report writing section provided in the physics practical workbook. Step number 3, your lab report will be evaluated based on the report writing skills rubrics. Step number 4, refer to your lecturer when to submit your lab report. The learning outcome of this experiment is to determine the moment of inertia of a flywheel. What is the moment of inertia? It is the name given to rotational inertia. The moment of inertia is analogous to the mass in the linear motion. Refer to figure 4.1. When the load of mass M is released from a certain height, it will move straight down with a linear acceleration of A. At the same time, the rigid body will rotate with an angular acceleration of alpha. By applying Newton's second law for the linear motion of the load, the equation 4.1 is obtained, where T is the tension in the string, M is the mass of the load, G is the acceleration due to gravity, which is given by the value of 9.81 meter per second squared, and A is the linear acceleration of the load. By applying Newton's second law for the rotational motion of the rigid body, the equation 4.3 is obtained, where A is the downward linear acceleration, tau is the frictional torque, alpha is the angular acceleration, T is the tension in the string, R is the radius of the axle, and I is the moment of inertia of the flywheel. We are plotting graph of alpha against T. Therefore, we require 6 sets of values of alpha and T. To calculate for the values of T, we use equation 4.5 to calculate for the linear acceleration A, where h is the falling distance of the mass and T is the time taken for the mass to fall to the ground. Then we substitute the value of A obtained from equation 4.5 into equation 4.1 to calculate for the tension in the string T. For the values of alpha, we use the equation 4.6. The formula of alpha is given by A over R, where the value of A is obtained using the equation 4.5 and R is the radius of the axle of the flywheel. Remember to watch the demonstration video on experiment 4 before you enter the lab. That's the end of this video session. Thanks for joining me.